Welcome back. This is 5.6 part 2. If you did not watch part 1, please go back and do so because this section is requiring us to do substitution with a definite integral. So I'm running through examples right now. If you watch the beginning, you'll have more of an idea of what's going on. All right, so we have a integral that says we're going from 0 to e of 1 over 2x plus e dx. Again, this looks super complicated. So the first thing I'm going to do is rewrite it. So I'm going to say 2x plus e to the negative 1 dx. Again, I can't take the integration of it. It's too complicated, so I have to use substitution. All right, so the first step is to do substitution. Let's let u equal 2x plus e. So therefore, du equals 2 dx. That doesn't look like my leftover because my leftover is just dx. So what I have to do is make it look like that by multiplying both sides by 1/2. When I do that, I get 1/2 du equals, and that should say dx. Okay, so now I'm good to go because both sides look the same. All right. Now, I also, in addition to having to do that, I have to take care of the upper and lower limits. Remember, they are currently in x and not u. So, for the upper one, x equals e. Now I'm going to plug that into 2x plus e. And when I do that, I get u equals 2 times e plus e, which equals 3e. This is my new upper limit, okay? So I'm going to highlight it because this is an easy thing to forget. The other thing I'm going to do is the lower one. So the lower limit, currently it's x equals 0. So plug that into u equals 2x plus e. So u equals 2 times 0 plus e. So therefore, this equals e. This is my new lower limit. Okay, so I have upper limit, lower limit. I'm going to go ahead and highlight this, okay? So the next step in all this is I have to write things in terms of u. So my integration is now going from the lower limit, which is e, to the upper limit, which is 3e. And then I have u to the negative 1 times, and what du is 1/2 du. So rewriting this by kicking the constant out, I get 1/2 u to the negative 1 going from e to 3e du. Now it's time to integrate. Okay, so I get 1/2. And guys, remember, u to the negative 1, I can't do negative 1 plus 1 because it'll zero out. But remember, this is saying this. 1 over u du, right? So the integration of 1 over u is actually ln u. Okay? I hope you guys understand that. Okay, so now remember, I'm taking it on the intervals in terms of u from e to 3e. So it's time to evaluate. So f at b, and we got to look up f at a. So I'm trying to find those values. So let's do f at b first. So that's the upper limit. So I get 1/2 ln of 3e, okay, and f at a equals 1/2 ln of e. Remember, ln of e is 1. So that's going to go away. So I just get 1/2 there. So when I subtract these two, I get 1/2 ln of 3e minus 1/2. Okay? So go ahead and put that in your calculator. Let's figure out numerically what that equals. So I'm putting 0.5 times ln of 3e and then I'm subtracting off 1/2. And I got 0.55 when it's rounded. Okay, all right, so that's how you do that problem. Now let's move on to example number 4. So example 4 is continuing on with the same thing. Evaluate the definite integral from pi over 6 to pi over 2, a cosecant squared x cotangent x dx. Again, this is complicated. So my advice to you is we got to figure out what is u and go from there. So if you look at it, I could rewrite this as pi over 6 going to pi over 2. I'm going to go ahead and put cotangent x and then cosecant squared x. And I'm writing this as leftover because I know the integration or the derivative of cotangent is cosecant squared, and that's why I'm doing that. So I'm going to substitute. I'm going to let u equal cotangent x. So when I take the derivative of cotangent x, I get cosecant squared x dx. And that is my leftover. Okay, that's the whole reason for doing that way. Okay, now I have to take care of the upper and lower limits. Okay, so let's do the upper one first. X equals pi over 2. So I'm going to plug that into the u formula. So you plug it in, u equals cotangent x. So u equals cotangent at pi over 2. Cotangent is a reciprocal of tangent, and tangent sine over cosine. So this is cosine at pi over 2 over sine at pi over 2. Okay, cosine at pi over 2 is 0 over sine over pi over 2, which is 1. So this is 0. So this is the new upper limit. Okay, so new upper limit becomes 0. Okay, let's look at the new lower limit. So lower, x equals pi over 6. So we're going to plug this in. U equals cotangent x. So u equals cosine at pi over 6. Okay, I meant to say cotangent, not cosine. So cotangent at pi over 6. All right, cotangent is 30 degrees. So I get cosine at 30 degrees over sine at 30 degrees. So this looks like this. Radical 3 over 2 is cosine at 30 degrees, and sine is 1/2. So radical 3 over 2 times 2 over 1 gives me a radical 3. So this is my new lower limit. Okay. Okay, so if I write this up, I'm going to have to use a -1 because a 0 is smaller. But I'm going to show you how this goes. So we're going to write this up. So currently, the new upper is 0, new lower is radical 3, right? And then we chose u to be cotangent x, and du is cosecant squared x dx, so it's just du. Okay, I can't leave this set because the lower is smaller than the upper. So the lower limit is supposed to be 0. This should be radical 3. You have to put the negative in front of it to switch the order of those upper and lower limits. Okay, now integrate. Okay, so this becomes u1 plus 1 all over 1 plus 1. So this is 1/2 u squared. Okay? And remember, because we have that negative hanging outside, it's negative. And we're going to evaluate it from 0 to radical 3. Okay, so time to evaluate. I'm trying to look for f at b and f at a. F at b, I'm going to plug this in. So -1/2 times the square root of 3 squared. Square root of 3 squared is 3. So this becomes negative 3 halves. F at A, negative 1/2 times 0 squared. So this becomes 0. So F at B minus F at A, when we do this, I get negative 3 over 2 minus 0, so it's negative 3 over 2. Okay, moving on. Last one, example number 5. Evaluate the definite integral from 0 to pi over 2 of tangent of x over 2. All right, so the complicated thing about this is what's inside the parentheses. Because I can take the integration of 0 to pi over 2 of tangent x, but what's causing trouble is I have 1/2 x inside the parentheses. So dx is my leftover. I'm going to let u equal 1/2 x. So that's my first step. Take the derivative of that. Oof. And that equals 1/2 dx. Again, that does not look like my leftover because my leftover is 1 dx. So I'm going to multiply both sides by 2 to get that done. And now I have 2 du equals dx. Okay, I'm good to go. So the u formula is taken care of. The derivative's taken care of. Now I have to do the lower and upper limits. So let's do the lower one first. U equals 0, or x equals 0, sorry. So I'm going to plug that into u equals 1/2 x. So 1/2 times 0 is 0. Okay, that's my new lower. So the lower limit didn't change, it's still 0, but it's in terms of u now. And the upper one is x equals pi over 2. So we're going to plug that into u equals 1/2 x. So u equals 1/2 times pi over 2. This becomes pi over 4. So that's the new upper. Okay. So now I'm ready to write. So I did all this substitution work. Now we're ready to write things up. So integration of from 0 to pi over 4. And then now we have tangent u times 2 du. So that's what I have. Okay. I'm going to go ahead and take the constant and put it out front. So 2 going from 0 to pi over 4, tan u du. Now it's time to integrate. So the integration of tangent is ln cosine u. And I'm taking this from 0 to pi over 4. Okay? Now we're going to evaluate f at b minus f at a. So f at b, I'm plugging in u equals pi over 4. So ln of cosine at pi over 4, that equals ln of radical 2 over 2. And then f at a, u, remember, equals 0. So ln of cosine at 0, so this is ln of 1, which equals e. Oh, sorry. No, it's not. It's, whoa, that's 0. Sorry, guys. That's why I stopped for a minute. I was like, is that right? No, it's not. So, a last step is take f at b minus f at a. So, ln of radical 2 over 2 minus 0 equals ln of radical 2 over 2. And that is my answer. You can plug it in into the calculator to see what you get. And guys, just a quick correction. I forgot the 2 there. So let me just fix this last problem. The integration should be 2 ln cosine at u. So when you plug this in, f at b, and like I said, let's do the correction right now. F at b is 2 times, whoops, I don't know what's going on with this thing. Let me just erase this little mark there. So it's 2 times ln, and then we'd have a 2 here. 2 times 0 is still 0. So the answer should be 2 ln radical 2 over 2. Sorry about that, but that's the answer. Okay, and now we're officially done. I just forgot the little coefficient there. So like I said, fix your notes. There should be the 2's where I'm highlighting. Okay. All right, and that's it.